Okay folks, this project is actually two in one. The first part is a memory keyer based on the K16 chip by Stephen Elliott, Kilo 1 Echo Lima. More details of that later. The second part is touch sensitive twin paddles based on a circuit by Mike 0 Uniform Kilo Delta, and that is Mike Parfrey. The two paddles there are made from printed circuit board, double-sided material, and as I said, they're touch sensitive, so you'll see that later when I do a demonstration. To the right of the paddles you can see a speed control which works in conjunction with the K16 chip. It alters the speed of sending of either the paddles or the memories. I'll give more details of both websites at the end of the video in the credits. So now let's move on and see the construction of the project. So this is John Parfrey's circuit. It's a very simple circuit. In fact, it's two circuits side by side, one for the touch paddle DIT and one for touch paddle DA. Now you can see there I used BS170 MOSFETs instead of the one specified by John, and it works perfectly. You can see the strap as well, the wrist strap. Now I did away with the wrist strap, but what I did instead was I put a nut and bolt and a washer on the top of the box, and I connected that to the positive 9 volts as shown in the circuit diagram there. And to operate the keyer, what you do is you place a finger on that washer, and that completes the circuit to the base of each of the Q1 and Q2 transistors, and I'll show that later on in some photographs. So this is a sanitized sketch of how I laid out the printed circuit board for the touch paddles. As you can see, there are two identical circuits, one to the left and one to the right, one for the DITs and one for the DAS. I hand drew a printed circuit board for the paddles, as you can see there in the photograph. Unfortunately, I didn't take a photograph of the components when they were mounted, except when they were installed inside the box. But I did a design, a rough sketch of how the printed circuit board was designed. So between the sketch and the photograph of the printed circuit board inside the completed project, you can probably figure out where the components were placed. Here's the touch paddle printed circuit board. Unfortunately, I didn't take a photograph of the PCB before installing it inside the unit, but you can see there the component placements. The two pads on the lower center, the left one goes to the DIT paddle and the right one, which is green, I think goes to the DA paddle. So I hope that's sufficient there to give an idea of the component placement. This is the schematic diagram of the K16 chip, and it can be customized depending on the number of memories you'd like to fit. I fitted 4 as shown in the diagram, and I also, instead of using the piezo speaker that's shown in the diagram, I fitted an 8 ohm speaker, but to drive the 8 ohm speaker I needed an extra transistor. The sketch you see, or the schematic you see above, is on page 24 of the on the website, the PDF on the website. The schematic for the additional transistor is shown on page 4, and that will follow. I'll post it here. There we go. There's the that's we can call that a 2N2222, but any general purpose PN, or sorry, I should say NPN transistor will do there. And you can see the speaker there. I fitted an 8 ohm speaker with the 100 ohm resistor in series. The collector of the transistor goes to the 4.5 volt pad on the PCB, and the base of the transistor goes to pin 3 of the IC chip. Here's a sketch I made for component placement on the K16 PCB. I use it as a guideline. It doesn't fit exactly on the etched PCB that I made, but it gives a good indication of where the components are and how they're laid out. So here's the PCB that I designed and etched for the K16 chip. You can see pin 1 and pin 8 are numbered, and the other pins are numbered 2, 3, 4, 5, 6, 7 and 8 anti-clockwise from pin 1. So with that layout of the PCB and the sketch that I've shown above, you should be able to figure out the component placements. Also, the next photograph, which shows the PCB populated and installed in the unit, that should help as well. And here is the completed K16 PCB. You can see the chip there in the center with the white dot, and it's wired in to the unit at this stage. You can see the 4 1K resistors on the bottom right hand side, and the wiring for each of the push button memories comes out from those points, each of the 1K resistors. The two outputs from the paddleboard PCB are wired into the inputs of the K16 circuit. And remember that the negative battery terminals of both PCBs are common ground, so make sure that you strap the two negatives of the two different batteries. You can also see on the bottom left the 4 memory buttons. The twin paddles are supported inside the front panel by a small piece of single-sided printed circuit board this time. What I did was I cut a U-piece in a small piece of board to accommodate the paddle assembly, and I left 2 small strips of copper exposed, and these 2 pieces, or these 2 strips, solder to the paddles. And the other side of the board has no copper at all attached, so it was just plain copper board, or well, not copper board, it was just plain plastic board. So I just super glued that to the inside of the front paddle, and that supported the paddle adequately. And here you can see the twin paddles where they protrude from the front of the enclosure. You can see the insulating material separating them. And as I said, the two inner surfaces of the paddles are grounded to prevent spurious operation by hand proximity. The volume, or not the volume control, but the potentiometer for the speed control is to the right of the key. You may recall from earlier in the video that instead of using the wrist strap that John Parfrey specified in his schematic, I used a touchpad which is on top of the enclosure. And to make the touchpad, I used a nut and bolt and two washers. This shows the inside of the touchpad, and I soldered a wire from the bottom of the bolt, and that goes to the PCB for the two touch paddles. And this shows the top of the unit, and you can see the touchpad there in the center. When using the paddles, in most instances you need to place a finger of your unused hand on top of that touchpad, and the touchpad is connected, as I said previously, to the 9-volt battery, and your body presents a high resistance from the 9 volts to the bases of the transistors when the paddles are touched. This is the rear panel of the unit, and on the left there is a 3.5 millimeter socket into which plugs the patch lead going to the transceiver. Just bear in mind that the output from the K16 PCB is like a straight key. It's not iambic, so it's just as if the unit was a straight key, and you'll have to program in your transceiver for that facility, and bear in mind that it's not iambic. On the right hand side there is an on-off switch, and that's used only on one of the PCBs. It's used for the board of the K16, which should last months even without an on-off switch, but just to be sure, I placed a switch there. John M0UKD says that it's not necessary to put an on-off switch for the paddle PCB, and that it should last for a lifetime. I never seem to be able to drill the holes for the speaker grill in a straight line, so to cover this I mounted the small speaker on the bottom of the unit, and that hides it from view, and quite happy with that. So enough of all the technical stuff. Let's see the unit in operation, both with the memories and also using the paddles at different speeds. Well, that's it, folks. Thank you for watching my video. I hope you enjoyed it. If you haven't already subscribed to my YouTube channel, then why not do so now? You can also leave a comment, which would be appreciated. If you'd like to contact me with any questions or seek any clarification on my build, you can email me on the email address that will follow in the credits shortly. So once again, thanks again. Guramaha Gwivilig agus Slán go fóil. 7-3 from Echo India, 5 Echo Mike, Tony in Dublin.